Chapter 7, Review, Part 3. Section 7.3, Finding a value when given a probability. Lesson objective, find a value of a normal random variable. Lesson objective, we will begin this video by learning a skill on how to work backwards. When given an area, how do we find the z-score that corresponds to the given area? We'll begin with this example. Find the z-score such that the area to the left of the z-score is 0.7157. This problem is a little bit different where instead of finding a probability and using a z-score, we are working backwards. We're taking an area and we're trying to find the z-score. The first thing that we do is go to table 5. We want to find the closest thing in the body of the table to 0.7157. Now it doesn't matter if it's over or under, whichever is closest. And if we look closely, we can see that 0.7157 is exactly in the table. And to get the corresponding z-score, all we have to do is look at the row component, 0.5, and the column component, 0.07, and add those two up. We see that the z-score such that the area to the left of the z-score is 0.7175 is the z-score of 0.57. Let's try another example. Find a z-score such that the area to the right of the z-score is 0.3021. Now we're given area to the right. Table 5 only gives us area to the left. So the first thing that we have to do is we have to find the area to the left. So we do 1 minus the area to the right and we get 0.6979. Going to table 5, again we're going to look in the body of the table and find the closest thing to 0.6979. Now looking carefully, we see 0.6979 is in between these two values, and we're going to use 0.6985 because it's closer. So this has a z-score of 0.52. So the approximate z-score that corresponds to an area of 0.6979 to the left or 0.3021 to the right is 0.52. Let's look at another example. Find the z-score that separates the middle 80% of the area under the normal curve from the 20% and the tails. So if we look at the picture here, this middle is 80%, and we have a tail here and a tail here. These two tails add up to be the remaining 20%. Therefore, this is symmetric. This is 10%, and this is 10%. So our first z-score, the area to the left is 0.1. So looking in table 5 to the closest thing to 0.1000 is 0.1003. That corresponds to a z of negative 1.28. To find the second z, the area to the right is 0.1, which means the area to the left is 0.9. So looking in the body of table 5, the closest thing to 0.9000 is the z-score 1.28. It actually has a probability of 0.8997. So to answer this question, the two z-scores that separate the middle 80% is z equals negative 1.28 and z equals positive 1.28. In this slide, this gives us the procedure for finding an x, given a proportion or a probability percentile or a percent. Our first step, we draw the normal curve and shade in the area corresponding to the proportion, the probability, or the percent or percentile. Second step, we use table 5 to find the z-score that corresponds to the shaded area, just as we did in the previous examples. Step 3, we use this formula to get the x value. Now I'd like to take just a second to show you where this formula comes from. It actually comes from the z-score. So in this case, we want to take the z-score formula and solve it for x. So we need to get rid of mu and we need to get rid of sigma. The easiest way to solve this is to get rid of sigma first, and since it's dividing the x, we want to do the opposite, multiply. So if we multiply both sides by sigma, these sigmas cancel and we're left with z times sigma equals x minus mu. And the last step is we want to add mu to both sides, and when we add mu to both sides we get this formula. Let's do an example. Mensa, the high IQ society, provides a forum for intellectual exchange among its members. There are members in more than 100 countries around the world. Activities include the exchange of ideas through lectures, discussions, journals, special interest groups, and local, regional, national, and international gatherings. The investigations of members' opinions and attitudes, the assistance to researchers inside and outside Mensa, and projects dealing with intelligence or Mensa. So this is straight from their web page. So the question is how do we join? Membership of Mensa is open to persons who have attained a score within the upper 2% of the general population on an approved intelligence test that has been properly administered and supervised. So in other words, anybody can join who has an IQ score that is in the top 2%. From our previous videos, if we do the Stanford-Binet IQ test, it has a mean of 100 and a standard deviation of 16. We're wanting to find what IQ score do you need to get in order to join Mensa. Okay, we know that the mean is 100, standard deviation 16. We want to find what is the score that you need. Clearly it's above 100. From the problem, we have to score in the top 2%, and 2% is the same thing as 0.0200. Table 5 gives us area to the left. This is area to the right. So our first step is we need to find the area to the left. And of course this is 1 minus 2% or 98%, 0.9800. This is the area that we want to look for in table 5. We know mu is 100, we know the standard deviation 16. We need to find the z-score that corresponds to 0.9800. So using table 5, looking in the body of the table, we want to find the closest thing to 0.9800. 0.9800 is in between these two values. It's actually closer to this one. That gives us our z-score. So our row component is 2.0. Our column component is 0.05. Adding those together, our z is 2.05. Going back to the problem, mu is 100, z is 2.05, our standard deviation 16. Multiplying these two together gives us 32.8. Add it to 100, and the score is 132.8. Since IQ scores are discrete numbers, we round this to 133. So in order to join Mensa, your IQ score would have to be 133 or more. Let's look at another example. What is the IQ score that separates the bottom 20% from the top 80%? Now, this is the same thing as saying what is the 20th percentile. Okay, our first step, we draw a picture. In this case, the score is going to be less than 100 because this is the 50th percentile. We are wanting the 20th percentile. So this area here is 20%. Using table 5, we're going to find the closest thing to 0.2000. And if we look in the table, we see the closest is 0.2005. That corresponds to a z of a negative 0.84. Substituting our values in the formula, mu is 100. Our z that corresponds to the bottom 20% is a negative 0.84. And then we multiply that by our standard deviation 16. This is the same thing as 100 minus 13.44. And we get 86.56, which rounds to an 87. So the IQ score that separates the bottom 20% from the top 80% is 87. Here's the readings and suggested problems. Thanks for watching.